Okay, moving on ahead to question 4. We've got Jeep B traveling at this constant speed of 20 meters per second at 30 degrees. So velocity of Jeep B, and that's with respect to the stationary guard A, is 20 meters per second at 30 degrees counterclockwise from east. And what's our other one? Let's see. And the other one is Jeep P is accelerating from rest at a constant rate of something something at some angle. So at this angle theta 1. Okay, so acceleration of, actually let's say velocity of Jeep P with respect to guard A initially was 0, and the acceleration of Jeep P with respect to guard A has been, what did we say, 0.55 meters per second squared. Well, I'm just going to say, I'm going to once again symbolize this. You know what? No, I'm just going to do it this way. 1.5 meters per second squared at, what was it? It was 52.0 degrees. Okay. Okay, so for part A, they're saying at a certain time they give us the speed of Jeep P, and what is the velocity of Jeep P relative to Jeep B at that time. So they're telling us what the speed is, but they don't tell us the direction. So we have to figure this out. Well, Jeep P started at rest, right? And then it started accelerating constantly in this direction. So if it starts accelerating in this direction, 52 degrees, then from rest, then obviously if it keeps accelerating in that direction, it's going to be moving in that direction. So its velocity is going to be in that direction as well. So velocity of Jeep P with respect to guard A is, I believe they said 26. Is that right? Yes. 26 meters per second. And that's also at 52.0 degrees. So guess what? We have to do components here. So the x component is magnitude times cosine of theta. I think you guys know this, but if you don't, it's just you go and review vectors and magnitudes and stuff. So velocity of Jeep P with respect to guard A is 16.0 I hat, and then 26 times sine of 52 is going to be 20. Let's see, right, plus 20.5 j hat, and this is all meters per second. Okay, and then at the same time, the velocity of B with respect to A, I'm just going to figure this out up here because it's easier. So at 30 degrees up is going to be 20 times, and the cosine of 30, which is also root 3 over 2, but what's that between friends, right? Is going to equal 17.3, actually not, I'm not going to put units in there, I hat, and then 20 meters per second at 30 degrees, the sine is going to be 1/2, so plus 10 j hat, and this is all meters per second. Okay, great. Now, what do we want to find? What we are asked for is, I believe, the velocity of Jeep P relative to Jeep B. Okay, well, so what we want to find is velocity of Jeep P relative to B. Now we have these three velocities we've got. We've got VPA, so velocity of Jeep P relative to the stationary guard A, P relative to B, which is what we're trying to find, and then B relative to A. So our rule is that we can stack these things together with subscripts and add them when the subscripts that are close to each other match. So we can do plus the velocity of P with respect to Jeep B is the velocity of B with respect to A, or sorry, plus the velocity of B with respect to A. Add them up and you get the velocity of P with respect to A. So what does that do for us? Well, VPB, we can actually, now that we've got this set up, we got the B's on the inside, right? So they add and it all works out nicely. Now that we got that set up, we can, can do whatever we want with the algebra. So we want to find this, and we know this and this. So let's rearrange it for the way we want it. VPB equals VPA minus VB BA. Okay, so now we just take, we can just take and do component-wise addition or subtraction of these things. So VPA is 16 I hat minus VBA, which is 17.3 J hat. So this is going to be negative 1.3 I hat, and then PA minus BA and J is 20.5 J hat minus 10 J hat. So plus, let's see, do 10.5 J hat. Boom, boom, meters per second. And they want this in magnitude and angle. So magnitude of VPB is, and that's just, so right, we take, let's see, 10.5 squared plus 1.3 squared, and then we take the square root of all of that. So how do I do that? Right, to the 0.5, and then that is, so magnitude of VPB is 10.6. And then the angle is just going to be arctan of 10.5 over negative 1.3. So let's see, theta for PB, I guess, is 10.5 divided by 0.3. Let me go back and insert minus, and let's see, inverse tan. And there we go, 82.9 degrees is what they give us. Is that going to be, oh, but that's not, that's, I didn't do a negative. Nope, my bad. So let's see, I just got to do this again. 10, negative 0.5. Are you excited to be spending your evening listening to me make mistakes? All right, negative 82.9, well, duh, all right. Good job, Smith. So that put me in the wrong quadrant. So if we look back at this picture, we can see that P is moving up this way and B is moving this way. So B is moving more to the rightish and then P is moving up. So we really, well, actually, we just look at our relative velocity vector. It's going to be back a little bit. You know, here's our negative 1.3 I hat, and then up like that. So it's going to be like this. So starting here, we're really going to be in quadrant 2. Not in quadrant 4, so we need to add 180 to get the 97.1 degrees. So let's hope that I got that right. Let's see. So 10.6, 97.1, submit, and then scroll back down. Yes, okay. Now what is the acceleration, sorry, of GP relative to GB? Well, this is actually easier because so again, we have this equation here, and we could go through the whole rigmarole we did in class. Actually, it's even better. We have this equation here. We can go through the whole thing we did in class, where we put deltas on each side, then divide the whole thing by delta t, and then make them all equal to a, or all, you know, say that's acceleration. But I think you guys know how that works. So acceleration of p with respect to b is acceleration of p with respect to a minus acceleration of b with respect to the a. We know all this because, you know, this is true, so this must be true. Now the acceleration of let's see, B, which Jeep is not accelerating? I think B is not accelerating, right? So let's see, G, right, so B is not accelerating, so this right here is 0. And this is what we want to find, which means acceleration of P with respect to B is the acceleration of P with respect to A. Same deal, because B is not accelerating with respect to A. So really that's all we do. And then they've been so kind as to give us the magnitude and angle for that. So we just take this, and what do we say? It was 0.55. In fact, we're just copying down numbers from here. 0.55 and 52 degrees. 55 and 52 degrees. And let's see. Yeehaw. There we go. Okay, I'll move on to the next problem.